Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at powers and place value. So we're really looking at how our number system is arranged. So here's the problem. We need to talk about numbers from very small numbers like 1 to very, very large numbers like 200 trillion. Now, we can't have a different symbol for each of those numbers because we just don't have the brain capacity to remember them all. So how are we going to get around that? Well, it's probably because we have 10 fingers. We have a number system that uses 10 different symbols from 0 to 9 inclusive. It's pretty easy to remember 10 symbols. But how then are we going to represent numbers bigger than 9? How are we going to represent numbers like 1,000 or 1,000,000? So what we do in our number system is we arrange these symbols in columns. So when you have a whole number, it is always to the left of a decimal point. Now, there are such things as numbers after the decimal point, decimal numbers or parts of a number. We're going to look at them later in the year. So to the right are those parts of a number. We're now just going to look at whole numbers. So they have digits arranged in columns to the left of the decimal point. So the first column to the left of the decimal point is the smallest column, is the ones, how many ones it has. And then the next column is the tens, then we have hundreds, thousands, 10,000s, and it keeps going for as long as you need. We go to 100,000s, millions, 10 millions, 100 millions, billions, and so on. So what are we actually doing when we represent numbers? Well, each of these columns is actually a power of 10. Now, you know now what powers are. So it turns out 10 to the power of 0 is 1, 10 to the power of 1 is 10, 10 to the power of 2 is 100, and so on. You can probably see a pattern here. When you raise 10 to a power, the answer is just 1, and the power tells you how many zeros. So 10 to the power of 3, 1,000, has 3 zeros. 10 to the power of 4 has 4 zeros. This number is 10,000s. So we arrange our numbers like this. So a number written like this, you might know it as 40,391. It tells us there is 1 plus 9 tens plus 3 hundreds, no thousands, and 4 10,000s. So another way we can write this is called expanded form. We write this as a linear combination of powers of 10. What does that mean? It means something times this power of 10 plus something times this power of 10 plus something times this power of 10 and so on. So if I want to write this in expanded form, it's 4 10,000s. So 10,000s is 10 to the power of 4. Now there are no thousands, so I don't need to write that. There are 3 hundreds. 100 is 10 to the power of 2. And then we have 9 tens and 1 ones in this case. So just note 10 to the power of 0 is actually 1. So a lot of people might think it's 0. It's actually 1. So this says 1 ones, 9 tens, 3 hundreds, 4 10,000s, and that's this number here, 40,391. Note here that 10 and 10 to the power of 1 are the same thing, so it doesn't really matter whether or not you write this 1 there. So if we have a number like 3624, so we have 3 is in the thousands column, so 1,000 is 10 to the power of 3, plus we have a 6 in the hundreds column, so 6 times 10 to the power of 2 means 600s, plus 2 tens, plus 4 ones. Now when you're writing the 4 ones, we often don't write the 10 to the power of 0. Whether or not you write it doesn't really matter. So this number written in expanded form looks like this. So this is just all about understanding how a number system works. So let's look at an example where we're going the other way. So here I have a number written in expanded form. What would be the number? Well, it might be easiest for us to start here at the ones. So there are 2 ones. There are 7 tens, so I put a 7 in the tens column. Then this just says 10 squared. That's the same as 1 times 10 squared. Because if you times something by 1, you don't change the number. So I'm going to put a 1 in the hundreds. Now notice there's no thousands, so I'm going to put a 0 in the thousands column. So next up we have 10,000s. So that is 8 times 10 to the power of 4. I'll put an 8 in the 10,000s column. Now we're missing 10 to the power of 5. 10 to the power of 5, 100,000s. Because it's not written, I'll put a 0 there. And we have a 7 in the 10 to the power of 6 column. That's actually the millions column. So ones, tens, hundreds, thousands, 10,000s, 100,000s, millions. This number is 7,080,172. And that's exactly what this says. 10 to the power of 6 is a million, so 7 millions, 8 10,000s or 80,000s, 172. All right, let's now look at a related number system called binary. So we don't use binary in everyday life, but it's needed in computers, which are rapidly taking over the world. So something you need to know about. So in binary, which is base 2, it has symbols 0 and 1. See, our system that I just showed you is base 10, and it had 10 symbols. But base 2 only has 2 symbols, 0 and 1. So again, we arrange numbers in columns, but we only use symbols 0 and 1, and each subsequent column is a power of 2. So I just want to point out, we use this little here to mean base 2, so you don't get confused, because you could think this is 101,101. This could be a base 10 number, so this little 2 tells us that it's in base 2. So in binary, the first column is still 1, so this is the column on the right, closest to, if you had a decimal point, it'd be there, closest to the decimal point. The next column though is 2 to the power of 1, so it's 2's. Then the next one is 2 squared, which is 4, so these are powers of 2. Then we go 2 to the power of 3 is 8. 2 to the power of 4 is 16, and then 2 to the power of 5 is 32, and so on. So the columns in binary, 1s, 2s, 4s, 8s, 16s, 32s, 64, and so on. You can see each column doubles. It's being times by 2. Each column is a power of 2. So if I want to know what number this is in base 10, well, I can just go and add it up. There's 1 in the 32 column. There's no 16s. There's 1 8, 1 4, no 2's, and 1 1. So if you simply add that up, you get the number 45. And I'm going to put a little 10 there to indicate that this is a base 10 number. So just adding this down here helps us when we're dealing with different bases. So let's look at this number 99, which is in base 10. I'm going to write it in base 2. So how do I do that? Well, just like I did in base 10, I want to write it in expanded form. So what that means is I want to write this as the sum of powers of 2. So let's find the highest power of 2 less than 99. So the powers of 2 are 1, 2, 4, 8, 16, 32, 64, 128. The highest power of 2 less than 99 is 64. Okay, so what do I need to get from 64 to 99? Well, that's 35. All right, let's now write 35 as powers of 2. What is the highest power of 2 less than 35? Well, it's 32. So I'm going to rewrite this 35 as 32, and I need 3 more to make 35. 64 plus 32 plus 3 is 99. Okay, but 3 is not a power of 2. So what do I need to do? I need to find the highest power of 2 less than 3. Well, it's not 4. That's too big. It's 2. So I'm going to rub out the 3, and I'm going to write it as 2 plus 1. Each of these are powers of 2. Now that I've written that, writing it in binary or base 2 becomes really easy. What I'm going to do is simply put a 1 in the 64 column, a 1 in the 32. The next column's 16, there were none of those. Next column's 8, there were none of those. There were no 4s, but there was 1, 2, and 1, 1. And I'll put a little 2 to indicate that this number is in base 2. It's not the base 10 number, for example, 1,100,011. So this in base 2 is equivalent to 99 in base 10. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.